today we're looking at advanced networking techniques for AV techs. Before I go too far into this, this is a very difficult course to do. This is at least going to be a very easy part that starts. And we're really just looking at the basic entry point right now for Wireshark and packet analysis. So today's one is going to be easy, but we're definitely going to go into much harder things over the next 3 weeks from here. So kicking it off, I will go into it. I can see I got plenty of confirmations that you can hear me, which is great news. So introductions. If you're not familiar with me, I am Malden Greenwood. I am the technical support manager for JPro. And the introduction part of this is actually going to start off with explaining why packet analysis is such an interest for me in particular. And I wanted to really explain this to make more of a interest towards you as to why I chose, me as an AV tech, chose this line of work that'll be worth considering. So when I started looking at networking as an AV person and deciding what I need to do, one of the obvious choices is CCNA comes up constantly. Everybody tells you to do CCNA. And I did a bit of it to start, but as I got deeper and deeper into it, I started seeing that we have problems on networks, and it has to do with how the data is moving from one point to another. So the outcome of that was I discovered packet analysis, and you'll understand through this presentation why that is the key role that I chose to do. But the point I'm trying to make is that if you're considering doing CCNA or some sort of networking course, as great as they are, hopefully by the end of all of this, you'll see the benefit of packet analysis as another field to look at. And for me personally, it was something I chose as quite a definite that I needed to do. And on the introduction side, I am not a network expert by no means. I'm an AV person, much like anybody in this presentation. And I'm aiming to teach all of us that have joined this to learn what packet analysis is. And predominantly, I'm trying to show you how I use it to solve problems as day-to-day issues come up. And that is the goal of all of this for over the next 4 weeks, is not to make you an expert at packet analysis, and you'll learn one of the reasons why that can be a bit dangerous, but is so that we all have a collective amount of information on how to use this very powerful tool and then go from there. I'm not a Wireshark certified expert. We can make that very clear from the get-go, but I know enough to date to help us deal with a lot of these problems that we keep running into. Anyway, let's get into the course. So starting off, this is what we're going to do today. Network packets. What is a packet? We have to understand the premise of what we're going to be doing and what it is. And then transport types, we need to revisit transport types, because when we learn about packet analysis, transport types is going to play a big role into how you see the data. So I'm just going to revisit that. A lot of you probably already know these protocols, but we're revisiting it as a broad, this is the expectation for the rest of the course. And then we'll understand everything going forward. Then we'll go into Wireshark. This course is going to be short today, but Wireshark, we're going to go into that where we're going to look at the warning, which will be very interesting for you guys to see, and capturing packets and filtering packets and methods, and then we'll get to the end of today. So today should be fairly short and straightforward. Please understand that this is an entry. Definitely the last one that we're doing on the 4th week, that is going to be a lot more in depth, a lot more of what you're expecting to see. But of course, you need to understand the base before you can move forward from there. Right, let's dive into it. So introductions to packets, what is a packet, and transport methods. So what is a packet? Well, a packet is essentially a bit of data that gets collected into a packet. It's kind of obvious what that is, but when you press a command on a keyboard and you say, I want to send this piece of data to a DSP of some nature or a projector, let's use the peon for the course. If I want to send the peon command, what happens on your computer is it collects a bunch of data, and you'll see what that data is as we go forward, and it assembles it into a packet. And it doesn't actually send it as one whole chunk all the time, depending how large it is and the type of protocols you're using. It actually breaks packets up. You would probably have heard of a thing called packet drop before. So what you see here is that instead of just one bit of the data going, it gets broken up into multitudes of packets that eventually get assembled, and then they get sent off on the network, but as individuals, and then they get reassembled at the other end. So as they're going through your network switch, something that you've sent will probably be broken up to like 5 different packets as an example. It depends on the protocols they use, but it all gets packaged into a packet, and that gets transported across. Now, this kind of leans onto why packets are interesting. Packets is the data. So when we're talking about sending a peon command and something stops it halfway and we want to know what happened and that sort of things, you can dig as deep as you want into a network switch configuration. That's essentially looking at what could have caused the problem. But at the end of the day, if you're able to actually look at the packet, you're able to do a lot more. And that's the goal of all of this, is seeing what is the packet. So at this point, we understand that a packet is a collection of data that gets assembled and gets broken up and gets sent across the network. As that's busy transported across the network, it goes off and it disappears. So this is kind of what it looks like. You have a bit of data inside that packet. And if you're looking at it quite deeply, this is what a packet actually looks like. A packet, and this is a snapshot from Wireshark as an example, it has a destination, a source, a type, and all of these things break down everything that's in a packet. So the actual command you're sending, the peon in this scenario, is this little bit of data sitting here at the end of it. But all of these factors here influence this packet. How is it going to be received? Where is it going? What's happening to it? What priority it carries? What protocol it is. There's quite a lot of information in this, and as we go through it, we'll understand more and more of it. But already being able to see the destination and the source helps us determine, oh, maybe I'm sending this to the wrong location. And we'll get into that much more. But what I wanted to show you is that a packet is a lot of information. It contains all of that plus the simple peon command that we're sending, which is contained down here. As we go into Wireshark, you'll see how that actually looks in practice. So network packets. So why focus on network packets? Well, you send a packet, it goes through a switch, then from the switch, it goes off and gets processed, and then from the switch, it gets sent again to the device you want to trigger. So in my scenario, my light bulb is my device. So what we have here is on my computer, I send a command that gets packeted on my computer and then gets sent. My network switch interrogates that packet. In some instances, it even takes the packet apart and reassembles it. That's kind of what you see in the layer 3 switch, where it will pull the destinations and those sort of things apart and then reassembles it and sends it back out again. So switches actually mess or politely play with the data. They manipulate it. And that data is then sent from that switch onwards to your device. But what we get to see here is that there's essentially 2 stages of where it moves from. So it moves from a laptop to a switch, from the switch to the device. 2 different areas, and we'll understand a bit more what that is. But the device receives it, and then it will normally execute the command of some nature. Light bulb goes on, right? So I've told the light bulb to switch on, the packet is received, and it executes from there. So what about another scenario? I send it off, it goes to the switch, it gets processed, the switch sends it off, and then it goes to the light bulb, and nothing happens. No light triggers on. And that's a very simplified version of what we're looking into here. But there's a scenario that most of us come across. It should be working. I should be the light bulb should be switching on. Something went wrong. How do I determine what went wrong is why you would be interested in packet analysis. So as we move into this is where Wireshark comes into play. Wireshark is the tool, it's a free tool, free piece of software you can download that allows you to look at packets. So it inevitably what it does is it strips the packets from your computer or wherever you've put it in the chain, and it pulls all the data that runs through that Ethernet cable to your computer, and it gives you all of it in a raw form so that you can go into every single protocol that's running, everything that's happening, and look at it in quite a lot of detail. But because if you think of it, this is what actually matters, is the packet moving from the computer or the device to the end result, to the unit that I'm trying to control or whatever it might be. As we go through this, you'll see how Dante moves and how video moves and a few other things that plays a big role into what we do every day. And as many of us, we struggle with networking in some form, like we have a network issue that's causing a problem, and we want to understand why that is. And Wireshark is the tool that can do that. So Wireshark is introduced to you now as that application that you can use. There are others. Wireshark just happens to be the most common and free one. Now, to go a little bit further, we need to understand transports. So as I've got a packet, a unicast packet, so this will be a term that many of you are familiar with, this packet will travel from here. So I send the command, it then goes off to the network, it then gets processed, and it goes to the device that I deemed it to go to. In other words, from this IP address to that IP address, it transports one way, one packet will go straight that way. Then there are other types of this. So when you send a packet and it's a multicast with no IGMP, this is what will happen. So most of you will be familiar with multicast. Now we're just going to see how this moves with no IGMP enabled. In other words, no multicast management enabled on the switch. So that packet left, one packet from my computer, my switch ends up duplicating it, and then it will send it to all the devices. So this is what commonly happens when you have a switch that isn't set up for IGMP or management of some nature. So the packets end up going to all the devices. Now, a very basic example, if you take a standard switch that is not a smart switch and you ran multicast through it, it will send the packet, the multicast packet, to every single device on the network. It's a big deal when you're looking at video, because on video, you're sending large data, sometimes up to 900 megs to devices, your decoders. And if your switch doesn't manage that data correctly, that data is going to end up going to every single device on the network if you have no IGMP on the switch or no multicast management. And this is typically where we see devices falling off the network or being flooded or not responding to commands. And it plays havoc on our network. Of course, most things will be set up with IGMP. So this is just an example again with IGMP. We see the data goes off, and then these computers requested the data, so then the data will go to them. They will get it, but the third PC towards the bottom doesn't receive the data. E.g., it controls the multicast based on who's requested it, and it will send it to those devices, and they'll receive it. I know this is very basic networking, but it will make a lot of sense when we're looking at how we use packets. So the next thing that comes up is called broadcast. So a packet goes to switch, and then what will happen is that it will broadcast it to all devices on the network. So these are the three types of protocols you get: unicast, multicast, and broadcast. And as you've seen with multicast, depending on your switch configuration, it will manage it to a certain degree. A broadcast packet, as you can see, goes to everything. A very good example of a broadcast packet is ARP, if you ever used that command before to scan your network to give you all the IP addresses in command prompt. That is a broadcast. It broadcasts out a request to all the devices on the network to say, what is your IP address or what are you? And it comes back and tells them, I am this. That's a very good example of a broadcast. In the AV world, we don't really use broadcast a lot other than for discovery protocols. And then also with some video, you can broadcast, but bearing in mind, it's going to go everywhere as a result. So those are the three types that we needed to understand for this. And moving into Wireshark warning. So I need to stress this quite seriously to all of you that are about to play with Wireshark. Wireshark sees everything on the network connection and captures it. Be careful where you use it and ensure you have authorization if you need any at all. It is considered a hacking tool to some IT professionals who don't understand it and those that do understand it. So in a brief explaining why you need to be careful, Wireshark, when your computer is connected to a network, whatever data is going to your computer, you will capture everything that your computer is able to receive. Now, if a network is well set up and the security protocols are very well done, it's not a concern because you shouldn't be able to see someone enter their password in somewhere or some pretty detailed networking information. Because Wireshark sees everything on the network, it will capture things like people browsing a website. It will carry all the data that's going through that website. So if they punch in their password, albeit encrypted, you will capture that information. This is why you need to be very careful where you use Wireshark. It's not that it's going to endanger you. It's just some IT person at that company, if you're plugging into the corporate network, could get pretty angry. Or if they've got policies and you've signed certain things, it could end you in serious trouble because you are capturing information essentially in a very raw form of it. And as I said, it is considered a hacking tool in some circles. And you'll understand a little bit more why that is in the next slide. But it can actually do some pretty interesting things because you're capturing the raw data of the network. So moving forward, when capturing packets with Wireshark, what you're able to do is choose where you want to capture the packet. Now, a good example is this one typically is you plug your computer into the switch and you're picking up the packets here. Now, this is where the transport protocols play a big part, is depending where you've connected. If I wanted to see Multicast that has IGMP enabled and I plug my computer in, I won't see the data if IGMP is enabled correctly or multicast control is enabled correctly, because I didn't request, or my computer never requested to see the video like a decoder does or anything like that. So if you plug it in this sort of connection, you won't see those sort of things. And this is where we learned the first really cool thing that we can use Wireshark for is if you wanted to see if IGMP was enabled correctly or not, or just a very basic test if multicast is working, doing that simple connection there confirms that only devices that requested multicast packets will receive them. Inversely, if you don't receive them, it means that it is set up correctly. I hope that part makes sense for the most of it, but basically it comes down to you will only see the data that is meant for your computer, that is actually being sent to your computer. So likewise, if a Unicast, if you wanted to send a message from your computer to a projector, you'll see it pass on this side, and you'll be able to read that message in its raw form with all the data available to you. But if I sent it from another device through the network, in other words, not through this connection, I won't see it because it's not passing through my laptop section. So this is kind of where we ask, well, how do we make more use of this? Because we want to read a lot more than that. Well, if you wanted to analyze the data here, for example, you would need to either mirror. Some of you might be familiar with port mirroring. You can port mirror on a switch. That means that all the data that's going from this switch to that light bulb, for example, is being directed out another port, and you can plug into that. Then you'll see all that data coming in to Wireshark. Likewise, there is another really powerful tool that we have, and that's called an ETAP. This is the solution to quite a lot of things, and it's a very powerful tool. An ETAP allows you to plug between the switch and the device, and the specific one that we have passes PoE, for example. And when you do that, you'll only see the data that's passing from the switch directly to that device, the light bulb. So quite a powerful device because it allows you to directly connect into the chain, in other words, here, for example, and be able to see what's happening. And the other very big benefit of it is that it also allows you to do this without having to do port mirroring or anything like that. In other words, I don't need any special configuration on a switch. This device will allow you to just sit between them and you'll pick up all the data. Now, the next part where I go into Wireshark, I'm going to show you the difference between the two. So you'll actually see how much data one and the other one's producing from each other. But the reason we had to understand transport protocols is because typically when you plug into this, a direct connection to the switch, you will only see the data between your laptop and the switch, and you'll see some multicast data depending if your laptop requested it. But more importantly, you won't see some because your laptop never requested it. And on top of that, understanding that you will see broadcast traffic, because broadcast goes to everything. So you will see ARPs and those sort of things coming through, and you'll see PTP packets and those sort of things. These sort of terminology we'll understand a bit better later. But that's a basic idea of how you capture the packets. Choose your point of entry, where do you want to collect the data, and bear in mind that what you see depends on what you can actually see on the network. Following this, we also start to understand, okay, something like this could be used in a very harmful manner. If I was to put this in between someone's computer and a network, and I had this device in the middle, I would see all the data moving between them. These devices are sometimes undetectable. Again, this is why some IT professionals will be very questionable to using Wireshark and a device like this. But if it's your AV network and their IT is not running on it or anything like that, there is no reason that you can't use this type of device. And you can plug in between the two. But as I said, keep in mind, wherever you do plug it, you are going to see everything that passes from them. Web page opening, device discoveries, all of it's going to be exposed. So moving on to Wireshark, filtering packets, and the demo of Wireshark, the bit that you probably all wanted to see today. So hopping over to Wireshark, this is Wireshark. Sorry, just give me one moment. So here's Wireshark running on my network. I have a small switch located behind me with a few Dante devices and a video device. And when you start up Wireshark, it presents you with this view, and it's the starting point. So I'm going to teach you very little on how to use Wireshark now in terms of doing a capture. And then towards the end, once we understand protocols and those sort of things better, then we'll get more into like how to analyze these packets and those sort of things. But for now, it's how to capture it and how to determine which ports, and then filtering, because filtering right now could be very useful for you, but also going forward with this training sessions that we're doing, filtering is going to be a key thing. So what we first get introduced with is the ports. So these are all my network connections on my computer. There is a fair bit, and we can see which ones we have. And currently my Wireshark is suspended. So I'll just get it started up. And already there you can see a lot of packets coming off. So once you get Wireshark running from the beginning, it will ask you which port you want to select. You just double click on it and you'll be able to see the live data moving through that packet. As I hop between these ones here, continue without saving, I'll be able to see the data moving through. So this is a bunch of data flying through my network switch right now. So this particular connection that we're looking at right now is me plugged straight into my switch. And I can see that this is the IP addresses and everything that's passing through my switch. And it's busy building a record of all the data that's passing through. So each one of these is essentially a capture. And when you do it on your own, you will see quite a bit of it coming through. And they have the source address, the IP addresses, and those sort of things all exposed to you to see. There is a lot of data passing through. It's actually nearly killing my laptop because of the amount of information that's passing. So I'm going to stop that and then just select another one for the connection. This is a very good example of how you could potentially almost kill your computer by doing this. Just give me one moment. I know exactly why it's doing that. Cool, that helps straight away. So if I select this port here and start monitoring on this one particularly, I've got 2 Ethernet connections. This one in particular will show me my whole network. So here I'm able to see the data moving between them. Correction, this actually is not my whole network. This one in particular is connection between me and Dante. So I've used that ETAP device. I've plugged from the ETAP in between the Dante device and a switch, and this is Dante, straightforward Dante passing through. And you'll notice that this in particular has quite a lot of packets coming through it. And I'm just going to stop it so that I can give you guys a better view of it by zooming in. So over here, ooh, a little bit close. I'll zoom out. Over here, I can see that this is PTP packets. I can see follow-up sync messages. I can see what device is transmitting, what multicast address it's running on. This really is Dante. So this is me injected between a Dante device and my computer picking up the communication between the switch and the Dante device only. So notice there is a lot less data on here. We're seeing tons of PTP messages, which we'll get into later what all of that is. But I can see the multicast address for the Dante, and I can see it's transmitting perfectly fine. And what I wanted to show you guys briefly was when we were looking previously at that chart from before, you could see quite a bit of information like destination. So there's an example. This is a packet. We're looking at the raw data of the packet. And over here, I can see the destination. I can see the source. So from this, I can determine what's transmitting it, where it's transmitting it. I can see the type. There's a lot of information inside this. But also with certain packets, like a UDP packet, which is your typical data packet, I can see here, for example, that this is the raw code, the raw information. Now, this won't look like too much, but as an example, if I was to send a peon command, which most people will be familiar with, it's the command that Epson uses for projectors, you can actually see the peon itself, or you can see the hex data of that command. So I've used this tool as a tool to discover, this app that I've downloaded to control a certain TV, what command is it using to switch on the TV? And when I push the button, I can actually capture that packet and I can dissect the packet. That sounds like a very extreme thing, but basically I can read the raw hex code and I can use that on another device. That's one scenario where I've used it before. More importantly, I can also see the ports. So if you're struggling to understand what ports you can use, if it's not very clear, or why does this one work and that one doesn't, this is where you can see the port numbers also. So I can see what the source port and the destination port is. So in the app scenario, I would be able to tell, okay, the actual port is 8708 as a scenario. So that's kind of a very teaser part of how we can look at Wireshark for quite powerful information. Because I'm plugged straight into my Dante, we're seeing a lot of PTP messages, which won't mean much to you guys. But if there was audio passing through this device, I would actually be able to see it. But notice something else that's come up here, and this is where we start seeing that little danger. Here's Dropbox coming up. So I can see it's a Dropbox LAN sync. It's using its own protocol, and I can pick up that data. I'm seeing that because Dropbox is transmitting something across my private connection that's got nothing to do with the internet. It's passing data through there. It's nothing serious, but that gives you an idea already of how powerful this is. You will see everything on that network connection, everything that's trying to do discovery, anything that's trying to pass, you will have full exposure on all of it. And the Dropbox is a good example of an app that's running on my computer right now, and it is passing network traffic through them. So always bear that in mind, that that's what you're seeing. Now, I'm going to move this over to my normal network. Hopefully, it shouldn't kill it now. I'll explain why that was. It'll be of interest. So here we can see a bunch of data passing through my direct connection to the switch. And over here, I'm able to see PTP again. Can very well explain why that is. And I can see other messages, UDPs, and so forth. I'm seeing the PTP because I don't have IGMP enabled on my switch. So I'm getting all the traffic, multicast traffic coming through. PTP is a multicast protocol. We can tell because it's 224 instead of 169 or some sort of IP address. So that's a very brief introduction to how you can already see all of this packet information, but let's put it to actual use. I want to now filter. So for many of you, this will be the question that you wondered is, how do I do filtering on something like Wireshark? Because it's great, I've got all this information, but it's super confusing because there's so much stuff coming up. So there's a few ways of doing it. If you've already started a session, you can just right-click and say, apply filter. And then you can say, apply filter on selected. And then that'll automatically assemble that filter for you. And now I can see all the traffic for that. I can see the PTP data, etc. There is another way that you're able to do it. If you select up here, there are predefined filters up here. The very common one I do is just select the IPv4 option and then punch in the IP address that you want on there. Now, it can be an IP address, it can be a multicast address. They'll all be visible. And that filters the traffic for you. It allows you to see all of it. So you still have this huge captured packet of data. But what you're able to do there is say, I just want to view the specific thing. A good example of this is if I wanted to view PTP only, I could apply the filter and say apply to selected over here. Prepare, apply, conversation, protocols, follow. Maybe not that easy, but you can just do it up here and go PTP. Select. That'll give you all the PTP information. So that's a good example where I'm using the protocol to determine to see all the information I'm looking for. So again, think of it this way. If this is a video over IP system and I'm not sure that my decoder is actually receiving the video, have I set up the switch wrong and I had the ETAP sitting between my switch and my decoder, I will be able to see, is the switch actually transmitting that video packet? Because I will know what the multicast address is based on the device. In other words, if I'm using something like AMX's SPSI, I'll know it's 239 or something like that, and I'll be able to see the traffic passing. If you don't see it passing in that scenario, in other words, you're in between the switch and the decoder, then you know there's something going on the encoder side or the switch side, and then you can start moving your way around. Because at the end of the day, if it doesn't come up on this, it's either very good at being secretive, which will be very impressive, or the reality of it is the packet's not passing. In other words, the traffic is not moving from the switch to where you're expecting it to be. And that's where we see this like, okay, this is quite powerful because I can use it to tell if something is actually wrong, or is it the switch, or whatever it is. I'll give you a very nice scenario that I've used this recently for. We have had some devices just firmware break badly, and we can't figure out why they look like they're working, but they aren't. And because I can see the MAC address, I'm able to determine what the device is. So this particular device that bricked itself, I could actually see the packets passing, and I could tell that, oh, okay, that is that device. And then from there, there was a couple more steps to it. But basically, I eventually was able to firmware reset the unit via this whole process. It's a very detailed thing, but you get the idea that just saying the unit's dead is one thing, but being able to see, okay, is it actually passing traffic? Yes, it is. I can work on this a bit better and get it working. A recent one that we've also had was a USB dongle, Ethernet USB dongle we were using was not functioning correctly with the software. And what we discovered was that when we opened up Wireshark, we could see the data coming through when we injected between them. So we knew it wasn't the device. And we knew when we injected in the middle that it's just the Ethernet dongle USB that was causing the problem. And then we knew straight away, okay, that's where we need to focus our data practice on, that sort of thing. So really think of it as a magnifying glass into the data that we're looking for. So a few other things about filtering that you should be fully aware of is that this is capturing everything. When you start Wireshark in the beginning, you can actually apply a filter right in the beginning. What it will do then is it will give you the filter option. So you can say, right, filter everything from the get-go in the beginning. So when you first start up Wireshark, it gives you this option. And then when you apply that, it will filter everything from there. In other words, you will not collect all the data. You're only going to collect the data that you wanted to see from the beginning. The difference is that if you're trying to troubleshoot something and you want to send the data to someone else, if you filter it on the initial start page, it will only give you that you intended to have. Can be beneficial. But if you filter it in here, up in the bar, or by using the right-click example, that will then filter from what's already been collected. In other words, you'll be able to remove the filter and see all the data, versus where you can't see it because you've already filtered it on the end. Think of it as filtering on the input versus capturing everything and then filtering something, as an example. Something worth knowing. And we will go over much more detail about all of this, especially the packets and those sort of things. But this starts drawing us closer to the end of this session. From here, you should be able to open up Wireshark, and you should be able to do a filter, capture some packets, play around with it and see what it does. And you should now understand why you might not see certain things and you will see some things. That pretty much covers today's session. Quick, but already I encourage you guys to go and start capturing things. Capture some packets for the next project, the next round that we go. I am going to send you packet captures that I've done with equipment using the ETAP, so you guys can use that for a test bench. But for now, play with Wireshark where you can, and play with the filters function.